Hi everyone, so this video we're going to look at parallelograms. So this video is just going to talk about the general parallelogram shape, but there are also videos on the special types of parallelograms, rectangles, and then rhombi and squares separately. Parallelogram is a type of quadrilateral. So remember when we have, going back to grade school, when we have different polygons, different shapes with multiple sides, right? We had triangles, 3 sides. Quadrilaterals are 4 sides. And quadrilaterals have several different groups within that name. Parallelograms are one. We also have trapezoids and kites. So for parallelograms, it is a special type of quadrilateral such that, and there is a very simple definition here, we have 2 pairs, and that part is important, 2 pairs of opposite sides parallel, and remember that symbol means parallel. And if we have a situation where we are told an opposite side in a quadrilateral, that means the sides that are across from each other. So DE is opposite CF and DC is opposite EF. And remember, the notation for parallel is the arrows on the lines we should use. If there are 2 pairs of parallel lines, such as in this case, we should use more arrows on different sets, just like we would with the tick marks for congruent segments. That's the definition. If you have a quadrilateral and 2 pairs of opposite sides are parallel, we call it a parallelogram. Parallelograms have several properties besides that definition. The first one is, in a parallelogram, consecutive or same side interior angles are supplementary. So actually, let me use the same markings as last time. So we have 2 pairs of parallel lines. So just for a short little proof, because DE is parallel to CF, and that was given, we know that angle D is supplementary to angle E, and angle C is supplementary to angle F. And that's because if parallel lines, then same side interior angles are supplementary. And again, remember, you could say consecutive. I'm just using SSI because it's easier in this case to abbreviate. So we have that, and we can say, by the way, that is also true for angles DC, D, and C, and angles E and angle F. So with this, we have, that's the first part. So we have, that should be C. We have the same side interior angles are supplementary simply because those 2 sides are parallel lines, and the other sides that cross them make a transversal. The same side interior angles are always supplementary. That comes from our knowledge of parallel lines and not from anything special to this shape. But the second one is, in a parallelogram, opposite angles are congruent. So again, opposite means across from. So for our angles, it would be D and F, C and E. Again, I'm using different symbols there because they're not all 4 congruent. So we would say that, again, if we want to prove that, we know that angle C is supplementary to angle F, and we know that angle E is also supplementary to angle F, and we proved that above. And so then we can say that angle C is congruent to angle E, because if we have things that are supplementary to same angle, then we know that they are congruent. And we can do the same thing Also true for angles D and F. So we have that. So if I tell you that EDCF is a parallelogram, then you can say EF is parallel to EF is parallel to DC, DE is parallel to CF, E is congruent to C, D is congruent to F, and then also the supplementary angle pairs. So there are two more properties we have with parallelograms. These are going to do with the sides. Now for the first one, we're going to pretend that diagonal EC doesn't exist. We're just going to use this one, DF. Okay. And we would like to show that we have two pairs of opposite sides that are congruent. Okay. So let's get started. So a couple things that we could say. We know that angle EDF is congruent to angle D. So EDF is congruent to angle DFC, and that angle, how do I want to call this one? What's the easiest way? CDF is congruent to angle DFE. So we have this. Okay. Now here's the thing. When we're going to do this, we have to decide then which triangles we want to use. I hope you got that. We're going to go for a congruent triangle proof here. So the easiest one for me to use is going to be this one. Or I should say this pair of triangles. Again, we're pretending that EC, actually I can move it out of the way, and I'm going to do that. So I have two triangles here, and I know, actually I should put my justification. We're using if parallel lines, or I should say that's an if and only if parallel lines, the alternate interior angles are congruent. So we have that. Now we also can say, remember that DF is congruent to itself, and that's going to be, of course, remember the reflexive property. Everything is always congruent to itself, and in this case we're using triangles, so we would always have then the shared side. That's the other way that I look at this. So I can say that triangle EDF is congruent to triangle CFD by angle side angle, and the way that I always show in class is I always put the little circular congruence mark on a reflexive side. And then I can say that sides DE and CF are congruent, and that sides DC and EF are congruent by CPCTC. Corresponding parts of congruent triangles are congruent. So I'm going to mark that. So we have this, and now with this we have the situation where going forward we can say more about these diagonals. Okay, now the diagonals in a parallelogram are a little bit unique in the sense that they bisect each other, but they are absolutely not congruent. So to start to prove why the diagonals bisect each other, we're going to use what we just did. So I'm going to say that, remember that we have DC is congruent to EF, and that's again going to be, we could say prove, but I'm going to use the real theorem. If parallelogram, then we have opposite sides congruent. So we have that, and I'm going to show you what triangles we're going to use. We're going to use this one, and we're going to use this one. And in order to do this, I'm going to drop in another point here at the intersection of the diagonals. We're going to call it G. So to do this, we're going to say a couple things. We're going to say once again that angle DFE is congruent to angle CDF. And again, parallel lines, if and only if, alternate interior angles congruent. And then after that, we're going to say that angle DGC is congruent to angle EGF, and that's because vertical angles are always congruent, and so I'm going to mark that. And then I can say that triangle DGC is congruent to triangle FGE by angle side. And then I can say that GE is congruent to GC and DG is congruent to GF, both by CPCTC. And then when we see this, now that's a little bit complicated now with all the markings there. That's the definition of bisector, right? EG is half of EC, right? Because we have those two equal pieces. So that's how we can see the diagonals bisect each other. Thanks for watching this intro video on parallelograms. Make sure to check out the others on squares, rhombi, and rectangles.